For decades, the bullet cluster has served as primary evidence for the existence of dark matter. This image captures a massive collision between two galaxy clusters. The hot pink gas represents visible matter, but the blue regions show where gravitational mass is actually concentrated, distinctly separated. Standard cosmology assumes an unseen mass of collisionless particles passed through without decelerating. This single observation, the physical gap between the gas and the gravity, is the anchor for the modern assumption that dark matter particles must exist. The Integrated Toroidal Syntropic Model, or ITSM, proposes a different starting point. It models the vacuum not as an empty void, but as an active medium called the superfluid plenum. If the vacuum of space interacts as a fluid, then the separation seen in the bullet cluster can be investigated as a problem of fluid dynamics, rather than a search for missing particles. In this model, celestial bodies moving through space experience a form of fluid friction, where the interaction depends on the density and speed of the matter involved. This approach suggests that the missing mass in these collisions might be a mechanical consequence of how different states of matter traverse this space fluid. To understand this mechanic, we have to look at the two components of the collision, the diffuse intercluster plasma and the dense stellar cores of the galaxies. When the clusters collide, the vast clouds of diffuse plasma slam into one another, creating intense ram pressure. This impact converts the plasma's kinetic energy into thermal X-ray emissions. As that energy is lost, the gas decelerates rapidly. The ITSM defines a speed limit for this fluid interaction, called the A0 kinematic yield threshold. Once the plasma drops below this threshold, it enters a state called acoustic lock. The gas loses energy to push through the vacuum, stalled by macroscopic fluid drag. The stellar cores of the galaxies, however, are compact and held together by intense self-gravity. Their density allows them to maintain their momentum, remaining unaffected by the ram pressure that stopped the diffuse gas. Because their kinetic energy stays above the A0 threshold, these cores move in a transparent limit, piercing the superfluid vacuum without experiencing the drag. This data plots the kinetic gap. Red contours identify the stalled gas, while blue contours track the stellar cores continuing forward. These velocity vectors show the matter states diverging, making the separation a measurable result of densities interacting with the superfluid vacuum. Even though the stellar cores move through the vacuum without slowing down, their passage through the plenum creates a significant structural effect. As shown in this topographical model, a high-density mass generates a metric wake, a structural distortion trailing behind it. In panel A's kinematic vector field, the extra gravity observed in the bullet cluster aligns with the shape of this fluid wake. This suggests that the gravity detected by astronomers is not generated by an invisible particle, but is the distortion of the space fluid itself. In this framework, gravity has not detached from matter. The stellar cores simply move forward, leaving a massive wake in the vacuum they passed through. This indicates that the primary anomalies of the bullet cluster may result from misidentifying the fluid dynamics of space as an entirely new class of matter. If the vacuum of space is an active fluid, then the universe functions without the need for dark matter particles. It only requires an understanding of the mechanics of the medium we move within.